Okay, welcome everyone. We're very happy to have our own Dr. Emily Adlam give our Institute for Quantum Studies seminar this week. I just wanted to give a brief introduction. I'm sure most of you are acquainted with Emily, but for those that aren't, she did her studies at the University of Oxford in both philosophy and physics, and then spent some time at the University of Cambridge working in relativistic quantum information theory. She went on to the Perimeter Institute and did some studies in the International Theoretical Physics program there, and then went to Western University where she was involved as a postdoctoral scholar in philosophy of physics. And now she has come to Chapman University as of this past summer and is a professor here in our philosophy department, and is also obviously very engaged in our Institute for Quantum Studies as well as the physics program. So Emily, we're looking forward to hearing about your new work about the combination problem for relational quantum mechanics.
Yeah, great. Hi, everyone. Thank you for coming, and thank you for the invitation. I just finished writing this about a week ago, so this would be a great time to have some feedback. So this project came about because I'm teaching philosophy of mind this term, and I was reading about the combination problem in panpsychism, and it struck me that this problem is very similar to a problem that I've been worrying about in relational quantum mechanics. So the idea of this project is to see if any of the many things that have been written about the combination problem in panpsychism can maybe help us see how to solve this similar problem in relational quantum mechanics. I should emphasize that I am not going to argue that relational quantum mechanics is a form of panpsychism. I don't think it necessarily has anything to do with consciousness. I just think that these problems are structurally very similar and thus might have similar kinds of solutions. So I'm going to briefly introduce relational quantum mechanics, and I will distinguish between two versions of relational quantum mechanics, the orthodox version and a version that Carlo and I proposed fairly recently. I'll then talk about panpsychism and describe the combination problem for both RQM and panpsychism and try to see how similar they really are. And then I'm just going to go through 4 different classes of possible solutions to the panpsychist combination problem and consider if any of them might possibly work for the RQM problem. So relational quantum mechanics is a solution to the measurement problem originated by Carlo Rovelli. The essential idea of relational quantum mechanics is that quantum states and the outcomes of quantum measurements are not absolute facts. They are relativized to individual observers. So for example, when Alice measures some system B, unitary quantum mechanics as applied by an external observer tells us that Alice and B end up in an entangled state, as shown here, where the states OI represent the possible outcomes and states CI represent the possible, the corresponding states of Alice corresponding to seeing the outcome OI. So from the external point of view, it looks like no definite outcome has occurred to this measurement, and Alice and B are just in this kind of big superposition state. But relational quantum mechanics stipulates that, in fact, this interaction creates a relative fact about the outcome OI relative to Alice, determined probabilistically according to the Born rule. So relative to Alice, there is a definite fact about the outcome of this measurement. Relative to the external observer, there is no definite fact about the outcome of this measurement. And therefore, of course, both Alice and the external observer will now be assigning different quantum states to the system B. So
I'm sorry. May I ask a question?
Yes,
So
yes.
when you say entangled state, it's exactly the entanglement definition of entangled states?
Yes.
Okay.
Yes, this entangled state. So there exist many different versions of this kind of perspectival solution to the measurement problem, including some versions of the Copenhagen interpretation, certainly some neo-Copenhagen interpretations, and possibly even cubism. So Rathbone is not alone in this position.
Sorry, Emily,
yes.
What's the meaning of the word possibly there? Why did you say possibly?
Well, cubism doesn't seem to me to have necessarily exactly one well-defined formulation. So some things that the cubists say about it seem like it's perspectival, others seem less so. So I'm not sure which it is intended to be. So yeah, RQM is not unique in this kind of claim, but what sets RQM apart in this class is that it tells us that any physical system whatsoever can play the role of an observer to which facts can be relativized. So most of these other approaches say that the role of observers are just played by sentient beings like us. RQM departs from that by saying that even individual fundamental particles are observers in the sense that they have facts relativized to them. So that means we need to generalize slightly the description I gave on the previous slide to cover interactions which don't look like an ordinary quantum measurement. So roughly speaking, we can imagine that when two arbitrary quantum systems interact, again, they're going to form an entangled state. For simplicity, let's assume it's a pure state. That means we'll be able to find a basis in which it takes the Schmidt form as shown here with no cross terms. And so I'll take it that RQM tells us that this interaction will create a relative fact for X, specifying a value of the variable V for Y, and also a relative fact for Y, specifying a value of the variable U for X, with both facts again selected probabilistically according to the Born rule. I should emphasize that according to Carlo, it is the interaction and not the resulting state that ultimately determines the relative facts. So really we should be figuring out the basis of the relative facts from the interaction Hamiltonian rather than the resulting state. But it doesn't seem that anyone has written down a sort of general approach by which you can extract the appropriate basis from the interaction Hamiltonian. So I'm going to take it that the post-interaction state as assigned by an idealized observer who knows the interaction is a sort of suitable analog for figuring out what the relative facts are going to be. Okay, so there are two different versions of RQM that I want to talk about. The first is what I'll call orthodox RQM, both because it is the original version and because it belongs to the class of what I refer to as the orthodox interpretations. So orthodox RQM says that there are no non-relative facts at all. So any meaningful physical fact has got to be relativized to some other observer. So one important consequence of that claim is that in orthodox RQM, it is impossible for information to be exchanged between two different observers because exchange of information would imply the existence of a non-relative fact about the connection between those two observers. So it is, of course, possible that from the point of view of a third observer, it looks as though information has been exchanged between the two observers, but that is only true relative to that third observer. It does not imply any intrinsic connection between the two observers. And indeed, some proponents of orthodox RQM have taken this as a virtue of their view. They suggest that it is sort of freeing us from this misunderstanding where we imagine that it's possible to think of a God's eye third-person perspective. They say that's just not meaningful. So, for example, DiBiagio and Ravelli write here that it is meaningless to compare events relative to different systems unless this is done relative to a possibly third system. So not everyone sees this impossibility of exchanging information as a problem. I, however, think it is a very big problem. And the reason is basically because the practice of science as we know it relies very crucially on exchanging information between different observers. And so it seems to me that we can't really meaningfully interpret a scientific theory in a way that denies the possibility of doing that. That would seem to make the theory self-undermining. So in response to those concerns, Carlo and I recently formulated this alternative version of relational quantum mechanics. Basically what we do here is just add a new postulate to relational quantum mechanics that allows the exchange of information between observers under appropriate circumstances. So basically this postulate, cross-perspective links, just says that if Alice performs a measurement on some system S and thus learns the value of some variable phi, and then Bob measures Alice in a basis which is suited to finding out Alice's information about phi, then Bob's measurement result will match Alice's measurement result. And so Bob will now know the same relative facts about the system S as Alice does. So they have succeeded in sharing some information. So that postulate, as we originally wrote it, is a bit sort of anthropocentric, but again, we can give it in a more general form as shown here. It just says that if our two general systems interact and form an entangled state with the Schmidt form as shown here, the original version of RQM tells us there will be a relative fact for S specifying that system Y has some value Vi of the variable V. And cross-perspective links just specifies that if you now measure X in the basis U, the result of your measurement will tell you the value of the relative fact for fact about Y for X. So if you obtain the result Ui, for example, you know that the value of V for Y relative to X is Vi. So that just says that it is now possible to move information around between different perspectives in this version of RQM. So it looks like perhaps a fairly small change, but I do think it is in some ways quite a significant departure from previous versions of RQM. In particular, this implies the existence of some non-relative facts about the connections between different observers. There are non-relative facts about whether or not two observers have the same values of some variable, and therefore we can't hold on to the kind of original vision of RQM in which all physical facts are relativized to something else. So in this paper, Carlo and I suggested that maybe the non-relative facts could be something like facts about some set of point-like events representing interactions between different physical systems. I'm not particularly attached to that version of the ontology. The key point is that there are now some non-relative facts.
So may I ask a question?
Yes.
So the CPL does one variable at a time?
Yes.
For any system?
Well, it depends on the Schmidt form. So usually there's just one Schmidt basis. Occasionally there might be more than one. So I'll talk about this more later, but in cases where there are two different Schmidt bases, you could potentially get two relative facts or more.
Okay, thank you.
Okay, so now to panpsychism. Panpsychism is a theory of phenomenal consciousness, which suggests that every physical system possesses some form of consciousness. So even individual fundamental particles have some kind of subjective experience or consciousness. So hopefully you can sort of see that there's structurally a similarity between RQM and panpsychism. RQM assigns relative facts to every physical system. Panpsychism assigns consciousness to every physical system. And indeed, you could potentially think of RQM as a form of panpsychism if you think of relative facts as being associated with subjective experience. I don't think you should interpret RQM that way. The reason is basically that this is going to make life harder. It's going to mean that there's an obligation to ensure that the relative facts at every possible scale are compatible with the kinds of expectations we would typically have about subjective experience. And that turns out to be pretty hard to do. And indeed, Carlo himself has noted that although there are connections between these two views, RQM is not really a form of panpsychism because relative facts don't have to be associated with mentality or subjective experience. So in this talk, I will assume we're dealing with a version of RQM which is not panpsychist. And that means I'll be using the term observer in a fairly thin way. So when I say observer, I will just mean a physical system to which we are allowed to associate some relative facts. That will not imply that the system has consciousness, knowledge, agency, or anything like that. It just means there are relative facts associated.
Just to be very explicit, Emily,
Yes.
so if I have two observers, observer A and observer B,
Yes.
I have facts for A and I have facts for B,
Yes.
but these facts don't have to agree with each other.
They will not typically agree. Certainly in orthodox RQM, that there will be no connections between them at all. In RQM plus cross-perspective links, you can create connections by appropriate physical interactions. So the combination problem in panpsychism refers to the fact that in order to be successful, it seems that panpsychism has got to tell us some story about how the consciousnesses associated with individual fundamental particles are supposed to combine to give rise to higher level consciousnesses associated with beings like us. And RQM, I think, has a fairly similar problem. RQM assigns relative facts to individual fundamental particles. It also needs to assign relative facts to human-sized systems because it's a big part of its solution to the measurement problem that different human observers have different relative facts. So it seems like we need to have some story to tell about how the relative facts for human-sized systems are related to the relative facts for individual fundamental particles. So even if the story they want to tell is that there's just no relation, they're totally autonomous, nonetheless, we would like to have a concrete story about what that relation is supposed to be. Current versions of RQM that I have looked at, as far as I can tell, don't really say anything about this. That seems like something that's missing in the current formulation of RQM. And so what I'd like to do here is try to understand what the possibilities are for explaining that connection. So hopefully you can now see why the panpsychist combination problem struck me as being so similar to the problem in RQM. I now want to sort of go a little bit deeper and see exactly how similar these problems really are. So let's start with an obvious disanalogy. The goals of RQM and panpsychism are not the same. Panpsychism has a number of motivations, but perhaps the key motivation is to solve the hard problem of consciousness, which refers to the fact that some people feel it's unclear how phenomenal consciousness or subjective experience could arise out of arrangements of microscopic non-conscious things. Meanwhile, relational quantum mechanics, of course, is primarily intended to solve the measurement problem of quantum mechanics. Those are two different problems. I personally don't think there's any reason to think the measurement problem has any particular connection to the hard problem of consciousness. So they are sort of working in different domains and looking at different issues. And that's, of course, going to affect the ways in which we would want to solve their respective combination problems. But although these are two different problems, I think there are some underlying commonalities in terms of the motivation. So one of the key motivations for adopting panpsychism as a solution to the hard problem is the worry that if we can't explain phenomenal consciousness in microscopic terms, we may in the end just be forced to regard macroscopic sentient beings as some kind of fundamental ontological category. So for example, that's what happens if you adopt some kind of dualism in which consciousness is associated with some kind of disembodied soul that is attached to human bodies. In that case, you have to treat humans as being sort of specially privileged in an ontological sense. And many people find that undesirable. Panpsychism is designed to avoid that issue by just assigning consciousness to every fundamental thing and just building the higher level consciousnesses out of the smaller ones. So that's why the combination problem is very important for panpsychism. If we can't find a compelling solution to the panpsychist combination problem, then it will seem equally unclear how macroscopic phenomenal consciousness could arise from a collection of microscopic conscious things. And then we may still be forced to treat macroscopic sentient beings as a fundamental ontological category. So meanwhile, in RQM, the goal is to solve the measurement problem, which may initially look different, but one of the main reasons we have a measurement problem is because most of us don't think it is plausible that categories like sentient beings and measurements should appear in a fundamental theory of physics. So those perspectival interpretations which address the measurement problem by treating observers as fundamental seem in some ways to not really be successfully solving it. So RQM aims to avoid that pitfall by assigning relative facts not only to conscious human observers, but to all physical systems. So again, in some sense, the motivation is to avoid having to treat sentient beings as a fundamental ontological category. Ravelli and Di are right here that the point of assigning relative facts to all of these different physical systems is precisely to avoid giving a special role to sentient beings. So the central mandate that RQM must fulfill if it is to be successful in this strategy is that we must be able to fully formulate its picture of reality without treating sentient beings, measurements, or anything of that kind as a fundamental ontological category. If we can't do that, then we won't really have gained anything by assigning relative facts to all of these fundamental particles. So we can now see that the combination problem in RQM is important for roughly the same reasons as the combination problem in panpsychism. Because if we can't solve the combination problem in RQM in a compelling way, we're going to have to just postulate macro observers without any sort of microphysical underpinnings. And then the concern is that we will still end up having to treat macroscopic sentient beings as a fundamental ontological category, and therefore we won't really have succeeded in the purpose we had in moving to RQM. So although these are different problems, they share this common motivation in wanting to avoid treating macroscopic sentient beings as a fundamental category. There are also similarities in terms of the extent to which these problems are susceptible to empirical inquiry. So in panpsychism, we cannot directly access the consciousness of any other observer. In RQM, we cannot directly access the relative facts of any other observer. And so in both cases, we can't directly establish how different consciousnesses or relative facts are related to each other. In panpsychism, we can, of course, gain some indirect information about the consciousness of another sentient being by asking them questions. We typically assume that we're getting meaningful information by doing that. But we can't really ask questions to fundamental particles about their subjective experience. So we don't really have an empirical way to establish how the subjective experience of the fundamental particles is related to the subjective experience of the being made up of those fundamental particles. So any solution to the question of how those are related is going to have to be essentially theoretical in character. Meanwhile, in RQM, in orthodox RQM, we can't gain even indirect access to anybody else's relative facts. But RQM plus CPL does allow us to indirectly access the relative facts of other systems in appropriate physical interactions. And so again, we have some ability to learn about other systems in that way. But the CPL postulate does insist that measuring a system disturbs its relative facts. And that means that if we're looking at a composite system made up of a collection of fundamental particles, if we measure one of those individual particles, we can't, to learn its relative facts, we can't then also learn the relative facts that the composite system had at the same time. And meanwhile, if we measure the composite to learn its relative facts, we can't then measure the individual particles to learn what relative facts they had at that time. So we can never learn all of the relative facts for the fundamental particles and the composite at the same time. And so again, we can't sort of directly empirically establish how these relative facts are related to each other. So in both cases, there's sort of limited means to address this problem by means of empirical inquiry. The solution is going to have to be theoretical in character. Okay, so sort of established that there are some strong similarities between these two problems, both in terms of the motivation and in terms of susceptibility to empirical inquiry. I now want to look in slightly more detail at a couple of different facets of the combination problem in panpsychism. So I'm just going to follow a classification provided by Chalmers here, who sets out three different key aspects of the panpsychist combination problem. So the first of those is what Chalmers calls the quality combination problem, which refers to the question of how micro qualities combine to form macro qualities. So qualities here refers to things like redness, or perhaps the experience of seeing redness. So the question is, whatever kind of subjective experience microscopic particles have, it presumably doesn't include the experience of seeing red. So how do whatever the subjective experience is, how do these all combine somehow to give the experience of seeing red at a higher level? So this strikes me as quite a hard problem. And so the good news for RQM is that it doesn't have a quality combination problem. So that's because RQM does not associate subjective experience with its relative facts. The relative facts in RQM can be expressed entirely in mathematical structural terms. They just describe measurement outcomes or quantum states, or predict possible future measurement outcomes. And so we can just capture them entirely in sort of functional mathematical terms. And that makes things easier for RQM. What's so difficult about the combination problem, the quality combination problem in panpsychism, is precisely that it's unclear how we could use the usual methods of physical science to describe how the experience of seeing red comes from some combination of individual subjective experiences for particles. We don't have that difficulty in RQM because it's all mathematical. We just essentially have a structural problem about relating the microscopic structure of the relative facts to the macroscopic structure of the relative facts. So in fact, the analog of this problem in RQM just comes down to what Chalmers calls the structural combination problem, and therefore I'll focus on that in discussing RQM. So the structural combination problem, as expressed by Chalmers, refers to the problem of saying how the structure of microscopic experiences relates to the structure of macroscopic experiences. And we do have a problem like that in RQM. We have to have something to say about how the structure of the microscopic relative facts relates to the structure of the macroscopic relative facts. Now, obviously, this problem would have a really straightforward solution if we could just say they have the same structure, but they probably can't have the same structure because of the preferred basis problem. So as a number of people have pointed out in criticism of RQM, in the case where the systems interacting are microscopic, there may be multiple bases in which the state that they form after that interaction takes the Schmidt form. So for example, the maximally entangled state will take the Schmidt form in every basis. So we can see that if we try to establish from that maximally entangled state what the relative facts created in the interaction are, it looks as though there will be a relative fact specifying that qubit 2 has either spin up or spin down relative to qubit 1. And there will also be a relative fact specifying that qubit 2 has either spin left or spin right relative to qubit 1, and indeed so on for all the other bases. And so qubit 1 knows relative facts about the values of qubit spins in 2 different bases. And in fact, more than 2, but at least 2. And so a number of people have raised this as an objection to RQM. They said, it looks like qubit 1 knows 2 incompatible facts about qubit 2. That's impossible. So qubits can't be regarded as observers. So DiBiagio and Ravelli have responded to this by suggesting, by emphasizing that claim that the relative facts are determined by the interaction and not the state. So there are different interactions which might produce that maximally entangled state. The hope is that specifying which interaction produced it is going to tell us what the relative facts are. So I don't think that's the right response to this criticism. The first reason is that, as Messino and Al point out, interaction Hamiltonians can also be written in different bases. It doesn't seem likely that it is always going to be the case that the interaction Hamiltonian singles out some specific basis in which the relative facts can be created. So pushing things back to the interaction doesn't really seem to solve this problem. And I also think it's just not really necessary for RQM to show that there's always a unique relative fact in every interaction. And that's because I've just said that relative facts are not associated with subjective experiences. So it's not really the case that qubit 1 knows two incompatible facts about qubit 2. Qubit 1 doesn't know anything. It's not conscious. It's not having a subjective experience. These relative facts are just kind of abstract structural relations. So there's really no reason why qubit 1 couldn't have two or more such relations with qubit 2. We don't have to be able to translate that into a coherent subjective experience. So I don't think this is a legitimate objection to RQM in and of itself, but it does indicate that we have a structural combination problem, because although it is fine for qubits to possess relative facts and incompatible bases, it is not okay for macroscopic observers to possess relative facts and incompatible bases. From our experience, we know that we only ever experience things as being in one definite state at a time. We don't find that particles have both spin up and spin left at the same time. And so it seems like we need to have some way of ensuring that by the time we get to the macroscopic level, the relative facts end up being represented in just one basis.
Sorry, can I just, because I thought observer wasn't defined in terms of consciousness. So wouldn't it be okay for a macro observer to have these incompatible facts if it's not conscious?
So macro observers in general could, we couldn't. So the relative facts are not in and of themselves associated with consciousness, but there is a claim being made that the relative facts, in the case where the system is conscious, the relative facts correspond to their experience and knowledge of the world. So my relative facts should correspond to the things that I know about the world. So not all systems with relative facts are conscious, but some of them are conscious. And in that case, the relative facts do correspond to their knowledge and experience. Make sense? Yeah, so we have a structural combination problem. We have to make sure that the structure of the relative facts changes as we move from microscopic systems to macroscopic systems. And obviously there's a clear way in which that should happen. It seems obvious that this must have something to do with decoherence. We know that decoherence selects a preferred basis as we move towards macroscopic scales. So surely decoherence plays a role here. And I think it should, but this is not automatic. We have to make sure we solve the combination problem in a way which actually allows decoherence to take effect. So for example, if your solution to the combination problem is to say the relative facts for a human observer are just the average of the relative facts of all the particles making it up, that is not going to solve the structural combination problem, because just averaging over relative facts isn't going to change the structure of the space of relative facts. So we're going to have to do something more complicated. We're going to have to make sure that decoherence in some way plays a role in the way in which macroscopic relative facts are produced from microscopic relative facts. Okay, so the final aspect of the combination problem is the subject combination problem, which refers to the question of how it is that microscopic observers or subjects of experience are supposed to combine into macroscopic observers or subjects of experience. So the first part of this problem is a concern about whether subjects can ever meaningfully combine into an additional subject. So in panpsychism, Goff has emphasized this problem by imagining something like a micro-experiential zombie world in which all the physical facts are the same as the actual world, and all fundamental particles have subjective experience, but macroscopic beings don't have subjective experience. That seems at least conceivable, even if it's not physically possible. And so Goff's concern is that it can't be the case that consciousnesses at the microscopic level just automatically by default give you a higher level consciousness. You need to add something to make sure that you get a higher level consciousness out of those individual consciousnesses. And similarly in RQM, you might imagine an RQM zombie world in which we say microscopic systems have relative facts. Those are all just the same as an ordinary RQM world, but there aren't any macro observers, there aren't any macroscopic relative facts. That again seems at least conceivable. And so again, that suggests that macro observers don't just automatically appear when we have collections of micro observers. Seems like something further must be added to explain why it is that we get a macro observer from some collection of micro observers. So this is roughly the conclusion that Goff reaches in the panpsychist case as well. He says that subjects of experience surely cannot sum merely in virtue of existing, but there must be some sort of state of affairs or relation between them, which explains why we get a subjective experience in certain circumstances. And likewise in RQM, it looks like we're going to have to say something about the circumstances in which observers combine into other observers. So one possible response, which has been advocated in panpsychism, is universalism. So the idea that every possible combination of microscopic subjective experiences combine into a higher level one. And the analog of that in RQM would be to say that every single possible subset of the fundamental particles in the universe is an observer with its own set of relative facts. That is perhaps the most obvious way to read the claim that Ravelli makes, that every possible physical system is an observer. So perhaps that is what Ravelli would intend. But I think that is not a very appealing answer for a couple of reasons. One is that it's just really hard to understand the meaning of those relative facts. If you just pick, three fundamental particles which are on opposite sides of the universe, in which have never interacted, those particles are not going to be able to interact in a coordinated way to perform something that looks like a measurement. And so their relative facts can't really be giving it any operational significance in terms of the observations that they could possibly make. So it's really hard to understand what it would even mean to attribute relative facts to that kind of collection of particles. We also get an analog of of the problem known in philosophy as the problem of the many. So the worry is that if every single subset of fundamental particles is an observer, then every human body is going to have millions upon millions of observers associated with it. Each of them will have their own relative facts. And certainly, at least in orthodox RQM, it looks as though those relative facts just won't be connected to each other. So this is starting to look dangerously like the many worlds interpretation, because what will happen in this picture when I make a measurement is that all of the different observers associated with me might see different outcomes. So we get something a bit like branching with different copies of me seeing different outcomes. So RQM is definitely not supposed to be a version of the many worlds interpretation. So I take it that this seems like a bad outcome for RQM. There's also a variation on the universalist view that Ravelli has suggested in some places, which involves identifying the contents of every possible connected region of space-time as an observer. This has just the same problems. For most connected regions of space-time, they're not going to form a unified observer which could perform anything like a measurement. And we're also going to have a problem of the many, because there are many different connected regions of space-time that you could associate with each body. So I don't think either of these universalist views look like a very appealing answer to this problem. So probably the way we want to solve the subject combination problem is to offer some criterion which picks out those sets of particles which are regarded as physical systems and which therefore constitute a macro observer. And there are sort of two ways of doing that. One would be to provide a criterion formulated using macroscopic categories. So for example, the criterion could be every sentient being is a macro observer. But obviously that would violate the central mandate. That would be essentially treating macroscopic sentient beings as fundamental. And so for any sort of choice of macroscopic criterion, there's a worry that we're essentially going against certainly the spirit, if not the letter, of that central mandate. So it seems likely to me that the appropriate way to answer this question is to give a criterion formulated using microphysical vocabulary. So for example, something like every collection of particles which has recently interacted counts as a macro observer. I don't think this particular criterion is successful, but something like that seems like, to me, the only viable route forward for RQM. Okay, so having set up the problem, I'm now just going to go through 4 different classes of solutions to the panpsychist combination problem. I took this classification from Chalmers as well, and I'm just going to see if any of these solutions look like they have a chance of helping us with the RQM combination problem. So first off, identity solutions. So in panpsychism, identity solutions are solutions to the combination problem in which we say the experiences of a sentient being are identical to the experiences of some microphysical system. So one way to do that would be to say the experiences of a sentient being are just identical to the experiences of some fundamental particle in her body. And we could imagine a similar version of this for RQM. That would involve saying that the relative facts of a macro observer are just identical to the relative facts of one of the fundamental particles in her body. So the obvious problem here is that this is not going to solve the structural combination problem. If my relative facts are identical to the relative facts of some particle in my body, then it would seem that I could very easily end up having relative facts defined in several incompatible bases at once, and we have specified that we want to avoid that. So that seems immediately problematic. It's also a bit odd in terms of how you choose that particle. If you just arbitrarily choose one particle, that seems poorly motivated and also has alarming consequences for mortality, because what happens if the particle, which is the bearer of my experience of the world, sort of leaves my body? Do I cease to exist? What goes on? So alternatively, we could say there's just one version of the macro observer for every one of the particles in her body, but that, of course, is going to lead to the same issues that I spoke about earlier in terms of the problem of the many. So this solution, I think, looks obviously unappealing in terms of solving the RQM problem. A different version of identity solution for panpsychism, known as the combinatorial infusion view. This one suggests that when micro experiences combine to yield macro experiences, they fuse together and cease to exist independently. So this approach is often combined with quantum holism, and the suggestion is that systems sharing entanglement should in fact be regarded as a single entity with a single consciousness. So because this is a quantum idea already, it's obviously tempting to think that maybe something similar could work in relational quantum mechanics. But actually, this would not work with RQM, at least as it is currently formulated, because we saw earlier that RQM tells us there are facts about some system relative to some other system only when those systems are entangled from the point of view of an external observer. So if we say that all entangled particles just merge into a single observer, we won't have any relative facts left at all. They have to remain distinct so that they can have relative facts about each other. And in addition, entanglement is so generic, we believe that this would potentially leave us with just one observer. But obviously, RQM with just one observer is not meaningfully relational anymore. So again, this doesn't seem like a viable solution to the RQM problem. So in summary, it seems to me that none of the identity style solutions are going to work in RQM. Okay, so the next class of solution is autonomy solutions. So in panpsychism, that involves saying that the experiences of macroscopic observers are just completely autonomous from the experiences of microscopic observers. And likewise in RQM, you could say that macroscopic relative facts are just completely autonomous from microscopic relative facts. There's no relation between them. So we can immediately see that's impossible in RQM plus CPL. The whole point of RQM plus CPL is that it creates connections between the relative facts of different observers. So it just can't be the case that macroscopic relative facts are always autonomous from microscopic relative facts. But this view is certainly possible in orthodox RQM. And indeed, I suspect this is probably the approach that most proponents of orthodox RQM would be inclined to take. So it's a possible view, but I don't think it's likely to be a very successful view. So one concern is that if we deny that macro observers are related in any way to micro observers, it looks as though we then have to just treat macro observers as being sort of fundamental in and of themselves. And then it seems that we're kind of in danger of violating the central mandate because we're moving pretty close to just treating sentient beings as a fundamental intellectual category. In addition, if macroscopic relative facts are autonomous from microscopic relative facts, that means that microscopic relative facts are not necessary for the existence of macroscopic relative facts. And yet, the whole point of orthodox RQM is that there are no non-relative facts. So if the microscopic relative facts bear no relation to the macroscopic relative facts, that means the whole microscopic world is just completely irrelevant to the existence of the macroscopic relative facts. And at that point, it's kind of unclear why we should even bother postulating a microscopic world at all. All we directly have access to is the macroscopic world and the macroscopic relative facts. If those facts are totally autonomous from the microscopic world, just throw away the microscopic world. What good is it doing us? So at that point, it seems like we should just get rid of the microscopic world. Perhaps that's an interesting view in and of itself, but it isn't RQM anymore because the whole point of RQM was to have this kind of democratic approach in which microscopic systems and macroscopic systems all have relative facts. So although I suspect this would be the route most proponents of orthodox RQM would want to take, I think this is not a good route for them to take. The third class of solution is what Chalmers calls the strong emergence approaches. So strong emergence involves cases where the emergent entities cannot be derived directly from the fundamental entities and the fundamental laws alone, but can be derived with the addition of some additional contingent laws of nature connecting fundamental entities to emergent entities. So the emergent entities can't be derived just from the fundamental stuff. You have to add these extra laws which just specify in certain circumstances some higher level being appears. So in panpsychism, that involves postulating contingent laws of nature which just connect certain micro experiences, possibly together with facts about microscopic physics, to macroscopic experiences. And likewise in RQM, we could imagine a case where we have contingent laws of nature connecting microscopic relative facts to macroscopic relative facts. So we have some strongly emergent macroscopic relative facts. So the problem with this view in orthodox RQM is that strongly emergent entities are usually thought of as being fundamental entities which are not grounded in the base entities or anything else. So if we take a strong emergence approach to macro observers, it looks like we have not little choice but to say that macro observers and micro observers are completely distinct from each other. They're not part of each other. They don't compose each other. They are distinct. And orthodox RQM is very clear about the fact that there can't be any systematic connections between the relative facts associated with different observers. So orthodox RQM seems to have to say that in the strong emergence case, the relative facts of the macro observers are not connected in any way to the relative facts of the micro observers. So in the end, this just ends up looking like the autonomy view, and it will have the same problems. So it seems to me that strong emergence is also not going to work very well in orthodox RQM. Strong emergence could potentially work in RQM plus cross-perspective links, but there's a worry that arises in the panpsychist case, which I think is also a worry here. So the worry is that in the case of strong emergence in panpsychism, the motivation for panpsychism in the first place appears to evaporate. If ontological emergence is possible, then why not simply accept that consciousness emerges in this radical way from a purely physical, entirely non-experiential fundamental substrate? And similarly in RQM, if we've figured out how to get macroscopic relative facts to emerge from the underlying stuff in a strong way, why do we need the microscopic relative facts at all? It seems if we can do that, and we can do that without violating the central mandate, it seems that we have already solved the problem. We've found a way of getting relative facts at the macroscopic level without treating sentient beings as fundamental, but without really having to worry about relative facts at the microscopic level. So the concern is that this approach will end up undercutting the motivation for RQM. And so if we can make this work, and it's unclear that we can, we would just have no good reason to believe RQM rather than some other kind of perspectival view. Okay, this is the last one. So combinatorial solutions to the panpsychist combination problem involve saying that micro experiences collectively constitute macro experiences, or macro experiences weakly emerge from micro experiences. And likewise in RQM, we could imagine a view in which the microscopic relative facts collectively constitute the macroscopic relative facts, or the macroscopic relative facts weakly emerge from microscopic relative facts, possibly together with other microphysical facts. So you might initially think that's impossible in orthodox RQM because orthodox RQM denies that there can be connections between the relative facts of different observers. But I think there's a possible way to make this work, because if we say that macro observers are literally constituted out of micro observers, then in some sense they're not really distinct observers anymore. So maybe the proponents of orthodox RQM would be okay to say in that kind of case, we're allowed to have connections between the relative facts because the observers are not really fully distinct. So there is potentially a combinatorial view which would work in orthodox RQM. But we are still quite limited in the way in which we can get to the macroscopic relative facts to emerge out of the microscopic relative facts. So orthodox RQM does still have to deny that the individual micro-observers can share any information because they remain distinct. So that means we can't use like some kind of dynamical process to create relations between them. We can't imagine that they sort of share information with each other and thus build up a unified higher level perspective which corresponds to a macro observer. And they just have to be completely distinct and independent forever. We also can't really appeal to facts about the arrangement or the interactions of the microobserver, because those facts are going to look different relative to each microobserver, and there's generally not going to be any sort of common structure which could be appealed to across all of the microobservers. So it seems like the only way we could get the macroscopic relative facts to emerge from the microscopic relative facts would be some kind of applying some kind of function to all of the independent relative facts for the microobservers to get the relative facts for the macroobserver. So that would be something like averaging or voting. You can't really make the function too complicated, because as soon as it gets beyond those sort of simple functions, it starts to look more like strong emergence than weak emergence. And then at that point, we would have to say that the observers are distinct after all, and then we wouldn't be allowed to have connections between them. So it looks like only something very simple like averaging or voting would be reasonable in this case. But as I noted earlier, just averaging over the microscopic relative facts is not going to solve the structural combination problem. It's not going to give you the kind of structure that you want for your macroscopic relative facts. And in particular, it's not going to solve the problem of having too many relative facts in different bases. So although it is sort of possible to have a combinatorial solution in orthodox RQM, I find it hard to see how that solution could work in a way which would give you the right kind of macroscopic relative facts. So things look a lot better in RQM plus CPL. That's because in RQM plus CPL, we can have sharing of information between microscopic observers, and therefore we are allowed to use dynamical processes to create a unified perspective via the sharing of relative facts. We can imagine that over time, the microobservers interact, cross-perspective links form between them, and eventually a higher level perspective arises through this sharing of information, creating unified perspective. But there is still a problem which sort of comes from the zombie argument I discussed earlier. So the thought is that if you imagine a case where a rumor goes around a crowd until everyone knows the rumor, now there's shared knowledge, right? But we wouldn't normally say there's some new collective entity to whom that knowledge belongs over and above all the individual people. And likewise in RQM plus CPL, even if all the individual micro-observers share relative facts until they all share some information, it doesn't seem that by default, that sharing gives rise to a higher level macro observer over and above all the individual micro observers. So it still seems like we're still going to have to add something to make sure we actually get a macroscopic observer from that combination of micro observers. So here we can appeal to an approach that's used in panpsychism. So Goff has proposed a phenomenal bonding relation which bonds subjects together to produce other subjects of experience. There are different ways you could do that within panpsychism. Chalmers imagines a co-consciousness relation involving states having consciousness of the same thing. We don't need to worry about those details. The point is that we can imagine doing something similar in RQM, right? We can postulate an informational bonding relation which holds between any pair of observers which have come to share a relative fact via an interaction as set out in the CPL postulate. And then we can just stipulate that whenever two observers are related by an informational bonding relation involving some relative fact F, then in that case, there will also be a composite observer present, which will possess the same relative fact F. So that means adding some sort of additional metaphysical heft to the cross-perspective links interactions, saying that not only do they involve the sharing of information, they also create a higher level observer. So one thing we should be careful about in defining that bonding relation, when a pair of observers form an informational bonding relation involving some relative fact F, it's important that we should attribute to the resulting higher level observer only the relative facts shared by both X and Y. We shouldn't attribute to that observer all of the relative facts possessed by both X and Y, because some of those facts might be inconsistent. So that means that when we construct higher level observers using this kind of bonding relation, the higher level observers may have less relative facts than the micro observers constituting them. And that turns out to be good news, because that is what we need to solve the structural combination problem. To see that, note that for an informational bonding relation to form, X and Y must interact such that their entangled states can be written in the Schmidt form, as shown here with bases U and phi. And then the same system X must interact with another system W such that their entangled state can be written in the Schmidt form with the bases U and Q. So the basis has to be the same for X between those two interactions. And then that is going to give rise to an informational bonding relation producing an observer composed out of X and W, which is in possession of a relative fact about Y in the basis B. So for microscopic interactions, that could involve basically any basis. There's no preferred basis at the microscopic level, but decoherence ensures that as the systems involved become large, effectively every interaction is going to produce a state which can be written in the Schmidt form as shown here, with a single basis B, where B is the basis favored by decoherence, usually just the coarse-grained position basis. So that means that as we get to larger scales, essentially every pair of interactions is going to produce an observer possessing a relative fact defined in basis B, but it's going to be quite uncommon for the observer to possess relative facts in other bases because there's no particular reason to think there should be other bases should be in common between two consecutive interactions. So that means that by the time we get up to a macro observer created out of thousands and thousands of these informational bonding relations, it's overwhelmingly likely that only relative facts defined in the decoherence basis remain. So this process of building a macro observer from micro observers seems to give us the result we want in terms of giving the right macroscopic structure. And I think it's nice that it does that by making proper use of decoherence. We didn't put this effect in by hand, we just used decoherence as a dynamical process in the way you would sort of naturally expect it to be used. Okay, finally, one possible problem for this view in the panpsychist case is to do with the question of whether the bonding relation is transitive. So the worry here is that if the relation is transitive and if the interactions that produce it are fairly ubiquitous, it looks as though all of the everything in the universe is going to end up being merged into one giant observer, which is a problem for panpsychism. And it seems like we might have a similar problem in the RQM case. So the informational bonding relation is not in fact transitive because if I share some relative fact with A and I share some relative fact with B, it doesn't necessarily follow that I share the same relative fact with both of them. So it doesn't follow that they share any relative facts. But of course, the relation of sharing some specific relative fact is transitive. And that does look like a worry for the panpsychist case because there are clearly some relative facts which we believe to be shared by almost the whole community of human observers. So it looks as though this approach potentially tells us that the whole community of human observers gets merged into just one observer. But as a matter of fact, I think this is not necessarily a problem in RQM because, as I emphasized throughout the talk, the term observer here just labels our systems to which we attach relative facts. So there's no reason why an observer could not include more than one consciousness. Indeed, we would expect the community of human observers to actually be made up of lots of different overlapping observers corresponding to the sharing of different relative facts between different observers. And that's not really a problem. That just tells us that there's distributions of shared information. It doesn't have any sort of, it doesn't mean that there has to be some higher level consciousness attached to the whole community or anything like that. I think one conclusion you might draw from this is that perhaps the term observer is not really that useful anymore in the context of RQM plus CPL. What really matters here is not which systems we identify as observers, but just the distribution of relative facts and how those spread across the physical world. So I'm tempted to say we should just adopt a kind of eliminativism towards macro observers and get rid of that notion altogether and just track how relative facts spread. But in any case, however you want to think of that solution, it seems to me that this solution is plausibly giving us what we need to solve the combination problem in RQM. It tells us how subjects combine. It seems to solve the structural combination problem. It seems to avoid the difficulties that come from having to treat macroscopic sentient beings as fundamental. Okay, so to conclude, I think the combination problem for RQM, although it hasn't been discussed much, is kind of a serious problem which needs a solution. And having gone through all of these possible solutions, it seems to me that the only one which has any chance of working is something like an informational bonding relation. So one conclusion I take from this is that if you didn't think that the argument I gave previously for why we should believe RQM plus CPL is better than orthodox RQM, these issues give you another reason to think we should believe RQM plus CPL and not the orthodox version. It seems like only RQM plus CPL is going to have a sensible story to tell about how macro observers are related to micro observers. So at that point, I guess I should stop speaking and see if anyone has any questions.
Questions? Matt?
So I want to just quickly outline how I would approach this problem. I want you to tell me whether this is viable or how where it fits into your categorization.
Okay.
So I don't really know how to say this, but what I want to say is that we should not talk about sort of strong emergence or top-down emergence necessarily, but maybe top-down supervenience. But still, it's the case that the macro facts are causally determined by the macro facts. So this is roughly how that would go. If I have a group of systems, then I can define the state relative to them.
Yeah.
And that determines what their relative facts, which observables are the relative facts. And then I can say, okay, well, if there's a subsystem of the observers, then those relative facts for the larger system must also be relative facts for the smaller system, although they may have more. Okay. This is going to ensure the kind of consistency that you need. But then you say, okay, well, that's how I'm defining things. But the actual fact, if you look at the physical interaction, you would have a situation where, okay, the measuring device gets correlated with this state, and then observer gets correlated with the measuring device. So at the point where just the measurement devices interact, there's a relative fact.
Yeah.
There's not a relative fact with respect to this observer here. But there is a relative fact with respect to the observer and the measuring device, because it is a measuring device. Then after the interaction, there's a relative fact with respect to the observer, which has basically been caused by the relative fact with respect to the measuring device. That has propagated up to the larger system, which is then. So I want to say something like this is an account where, although we're defining the relative facts for smaller systems in terms of the larger systems, they're actually caused by, temporarily they're caused by relative facts of smaller systems. Does that make sense?
Yeah, I mean, I think if what you want to say is that the relative facts for those different systems are actually related to each other in some way, that they're the same or similar, you can't do that in orthodox arguments. You have to do it.
I understand this is a version of plus acronym.
Yeah. And so I think what you've suggested seems the same as what I just said about informational bonding relations. I would have to see the details, but yeah, the thought there is indeed that facts get shared by interactions, and that builds up a higher level perspective. So I think that is the same kind of proposal. But yeah, I would have to discuss the chapter.
Okay, another question, Kelvin?
I'm still a little bit puzzled as to why a macro system can't have relative facts in different bases. It's being restricted by consciousness, but you might think consciousness is restricted in terms of what it can experience. But maybe we could talk about that later. I had a different sort of question, which is, if you're looking for an illuminating analogy, I'm wondering why use the combination problem for panpsychism. So there's another problem in philosophy that's maybe more general, which is the special question of composition, a question of mereology. So this even applies in just classical physics. Under what circumstances do some objects compose a further object? You have universalism, which says always, nihilism, which says never, and then restrictionist views that say sometimes, and they try and give a restriction. And especially in the restrictionist camp, you have like these ideas of strong emergence and autonomy coming up as well. So was there anything particular about the panpsychist combination problem that's useful, or could you say use the composition question in mereology to illustrate this as well?
Yeah, so I mean, I think the composition question corresponds roughly to what the subject combination problem. And so the reason I find the panpsychism case still somewhat more illuminating is because the question is not just which sets of micro-observers form a macro-observer. The more important question, I think, is how are the relative facts for the macro-observers related to the relative facts for the micro-observers? So that seems to me a closer comparison, because in the composition problem, we're not necessarily trying to translate. There doesn't seem to be any obvious analog of relative facts in that case, whereas in panpsychism, there certainly is, because it seems important for the panpsychist case that there should be some relation between the consciousnesses at the higher level and the consciousness at the lower level. So that's why I think the subject combination problem is one aspect of this problem, but it's not the only aspect.
Questions? Justin?
Two questions. The first one is that if I understand you correctly, RQM seems to be basically assuming unitary dynamics, like a closed system, everything's unitary, there's no extra collapse process, something of that sort. Is that
So
right?
everything is unitary from my point of view until I make a measurement. It's non-unitary in the sense that when I make a measurement, I see a definite outcome. But
Okay, so
until I perform a measurement, everything is.
so it is including a possible collapse measurement, something in there.
So it doesn't describe it in terms of a collapse. It just says that a relative fact appears during the interaction in a single basis. But kind of the effect of that is that it would look like something has collapsed for me.
Okay, so then my actual question there is, has RQM analyzed a case where you combine these two types of information? For example, feedback control. You're making measurements using the information you measure to then influence the unitary dynamics in some controlled way. Have you analyzed that in an RQM sense? Because it seems like it would be an interesting case.
I agree that would be an interesting case. I haven't seen that analyzed. I think a lot of writing about RQM tends to be quite qualitative rather than in studying specific quantitative cases. And I think it would benefit from considering more quantitative cases like that.
That's why I was suggesting that example.
As I say, for example, the relative facts are supposed to be a consequence of the interaction rather than the state, but I could not find anywhere anyone who has written down how we're supposed to get the relative facts from the interaction.
It has to be both. You can't just have their interaction and just the state.
Yeah.
Decoherence and decoherence theory.
Right. Yeah. So I think there are some things which need to be made clearer about the exact formulation. Yeah.
And second question is that it seems from your discussion that there's a lot of emphasis placed on subsystem identity. Like
Yes.
you know what the subsystems are,
Yeah.
and then you compose them, and then they share back.
Mhm.
Does RQM comment on the fact that once I have a joint quantum system, there is not a unique way to factor it into subsystems? Every choice of factorization, you're going to have different notions of entanglement, different possible bases, freedoms, and all of that. So the freedoms there go beyond just choice of basis of fixed subsystems. The choice of subsystems is also pretty loose.
Yeah, I think Carla would probably just want to say all of those subsystem systems are legitimate observers and they all have their own relative facts. Certainly in orthodox RQM, because there are no relations between them anyway, it's totally fine to have as many observers as you want with distinct relative facts. Things become more complicated if you want to say there are connections between their relative facts. This is a fairly recent addition to RQM, so not that much work has been done on figuring out what it would look like. But I think that's definitely a good question to see how that would pan out in a case where you do say there are connections between observers.
Right. It seemed relevant to me since you're building up things compositionally. That
Yeah.
it completely change what the subsystem identities are. That would change the stories.
Yeah, I mean, it's not clear that orthodox RQM does intend to build things up compositionally. I think it's a problem if it doesn't, but also none of the writing that I've looked at really sort of addressed whether that is supposed to be the case or not.
So I have a question about this compositional story about consciousness. So if you attribute every particle has some quantum of consciousness, to abuse of a word, I start combining things. Why isn't it true then that a mountain would have more consciousness than an ant or this sort of thing? So you mentioned this ability of being able to integrate the consciousness in some way.
Yeah.
Clearly, just combining more things together doesn't, at least maybe on one view could have. Maybe some people would say, yes, a mountain does have more consciousness than an ant, but can you respond to that?
Yeah. So I mean, that's I'm not an expert on the panpsychist things, but I guess one constraint you would probably want to put on the solution that you have to the combination problem in the panpsychist case would be, you would like it to tell you that the right kinds of things that are expectations of what things have, what level of consciousness. So there are sort of specific versions of panpsychism. Like I think integrated information theory is in some ways a version of panpsychism, and that has a specific way of measuring the level of consciousness, which is to do with how integrated the system is. And so using that kind of measure, it comes out that your brains are more conscious than mountains and so on. But certainly that's not automatic. In panpsychism, you're going to have to build that into your solution to the combination problem to make sure you get the results you expect.
And then my other question was, you started out with the relational quantum mechanics and the panpsychic as sort of two different cases. You had parallels, but you didn't have to combine them. But then by the end of the talk, it seems like the ideas had kind of gelled together in one thing, so that somehow the relative facts became conscious, and it wasn't clear to me when that merger took place, or if that was just one solution to some of the problems you raised.
So I didn't intend to merge them in any way. I was just intending to use the solutions that have been proposed for panpsychism to inspire possible solutions to the argument problem. So that the informational bonding solution I suggested, for example, is not intended to be committed to any claims about consciousness. It's structurally similar in that it has the same property that when we have certain kind of interaction that produces a high level subject, but that subject is not need to be conscious.
Okay, any other questions? Oh, yes, Abhishek?
So the thing you mentioned about transitivity, going back to what Justin mentioned, well, when the identity of what you call an observer is unclear, when you can't factor out systems or whatever, how do you reconcile transitivity?
So with the way that observers are created using the informational bonding relation, it's true by definition that a higher level observer arises only if there are shared facts. So I would think that what you would see in that case would be that all of the higher level observers would share roughly the same relative facts because they're all made up of out of the same particles sharing certain relative facts. So, I mean, I haven't examined this case in any sort of quantitative detail, but my expectation would be that because you have this sharing of information, all the different factorizations would produce roughly the same relative facts.
Okay, let's thank Emily for a nice talk.